Set a market order 'cause I'm pretty Hey guys, welcome to tutorial 7. Today we actually don't have much to do, which is good because I wanted to go a bit over question number 3 from your current assignment. Someone last tutorial mentioned it, kind of about how like it was really hard or something with the requests. So I did some reading, and I've got good news. It's not nearly as complicated as it might seem. So I'll go over that. Yeah, no problem. But besides that, we still have to cover a bit of the content first, so we can do that. All right, cool. Let's get started. So the first thing we want to do is we're basically following these instructions. So we have to write an algorithm. Students, that's you. We're going to read a file and add prepended line numbers followed by a tab character to the string, and then we're going to write that into a second file. So this is a bit of practice with file IO, file input output, because that's important and it's also on your current assignment. So this is what our input's going to look like, and this is what we want our output to look like. So if you take a look over here, we have an input limerick.txt. So where is this file? Because it matters. You'll notice that if you go here to my file browser, this Jupyter Hub Python file that I'm running is tutorial7.ipynb, and the limerick.txt is in the same folder. So that's important because it will let us very easily reference the file. And I'll show you guys what I mean. So we can start off writing our function. We can call it limerick. And all it does is it transforms our input. So the first thing we need to do is figure out how we're actually going to get the input to work in Python. And getting text files as input is actually pretty simple. All you have to do is use the following command. And I'll actually show you guys. Just so you know, everything I tell you guys about input output, like you can find everything on the docs, on the Python documentation. So all I did was I searched Python input output. You know, it brings you to this page. You look at the table of contents and you see, boom, 7.2 reading and writing files, which is exactly what we want to do. So it turns out what we can do is we can use the open command, where the first argument is a string containing the file name, and the second argument is the mode right here. In the mode, we either use R if we want to read to the file that we're referencing, W if we want to write to that file, and A for appending. That's really all we need to know. So we can basically just follow this. So I'm just going to copy this, and we can go back here, and boom, you have that. Except instead of work file, we need to actually have the file path that we're talking about. So in this case, it's going to be limerick.txt. And we don't have to add any file paths, right? Like anything like this, because it's in the same folder. So we can just leave it like that. And what we want to do is we actually want to read from that file. But you'll notice that the instructions say that we're supposed to write our output to a second file. So what we actually need to do is we need to create a file to output to. So let's actually rename this. Instead of F, let's call it input file. And that way we can make another one and we can call it output file. And for the name, we can actually make a name right now, because when we open this file, since we're writing to it and it doesn't exist, Python's actually going to create the file. So we can call this output.txt, for example, and our mode is going to be write, because we're actually writing to this file as opposed to reading it like our input. So next thing we want to do is we want to actually read the content. So you'll notice that if we do something like input file dot read and run that, we do this, or actually, yeah, so that works. We just have to call our function first. Limerick All right, let's try printing it. Here we go. So there it is. This has nothing to do with this text up here. It actually got this from the input file. So it went into our file folder, it found limerick.txt, which is right here, and it basically grabbed this text. And that's what the read function does, right? Instead, a cool thing, right? If you notice, this is actually all one piece of text. So we can split it up by line. And the way to do that is, instead of using the read function, we can use read lines. And you'll notice now we're getting something different. Now we're getting a list. This is a list where each element of the list is one of the lines. And you'll notice that it still has the new line character on here, which when you actually write that to a file and try to display the file later on, things like new line characters and tab characters actually get converted into the visual representation, which is actually creating a new line or actually creating a tab. So yeah, this is important because we want to read lines as opposed to reading the entire content, because we're trying to work with lines. We're trying to add something before each line. So what we can do, right, let's remove this print statement, is we can make a for loop. And we can basically say, for line in lines, let's actually first make the lines. We'll say lines equals input file dot read lines, right? So this is now storing that list of lines, this list right here, it's storing it in the variable lines. So now we can say for every element in that list, where every element is going to be one line, we want to put a number before it, and we want to write that to the output file. So let's actually create a counter variable as well. Let's say counter equals 1, because we want to start at 1, right? And then we can say output file dot write, and then we can say what we want to write to the output file. So it says in the instructions, we want to have the line number followed by a tab character. That's what this is, right? A tab character to the string, and then write it to the file. So we need to say something like write our counter, whatever that number might be, as a string, because we're going to concatenate it, plus a tab character, which in Python and many programming languages, once again, it's represented as a backslash followed by a T. And then we're going to concatenate to that the original line, right? We want the original line. So we can say line, right? Because we're doing for line in lines. And of course, we want to increment our counter so that the next time we use our counter, it's 1 higher. And here's an important thing. If we go back to the docs, you'll notice that somewhere it says it, but when you open a file, you should close a file. So right here, f.close, this function closes the file. So if you try to read from it after you closed it, it gives you an error. It says IO operation on a closed file, which is invalid. So you should always, it's good practice to always close your files that you open, so that they don't continue to use computer resources. Because like while they're open, Python is still like using RAM and stuff for that, and space. So we can just say input file dot close, output file dot close, and that's basically it, right? If we run this, you'll notice nothing actually happens. But if we go back to our file directory, you'll notice that there's a new file here, output.txt, and its last modified is seconds ago. And that's because Python actually made that file when we wrote to it. And if you open it, you'll see, ta-da, there's our correct output, right? You have the prepended line numbers followed by a tab. This is representing a tab right here, that kind of arrow thing, followed by the line. And it's the exact same as the limerick, right? Except for it has the correct changes. So that's pretty simple. And it's also a bit boring. There's one cool modification that we can do. We can go a bit further. So what we can do now is we can make basically the same thing, but let's try making it so that I don't know if you guys heard of Mad Libs, but basically we're going to try and make this a Mad Lib, which we're going to replace all of these words that are in single quotes with a random word. So let's try and do that, right? Let's say we'll say custom limerick here. And we're going to have basically the same stuff. Except now we got to think about it, right? Because now we actually want to change things on a word by word basis, which means we don't want to separate all the lines because then it would kind of be hard to go through them. And I'm sure there is a way to do it by using read lines, but the way I thought about it is by just using read so that we get our whole content, right? Like all the content, and we can call that content. And then what we can do is split only by new line characters. I don't know if you guys remember splitting, but it basically separates a list or like a string into a list where each element is separated by whatever character you specify. So we can say our lines are going to be the content where it's split by a new line. Right? And now let's oops, this is our original thing. Don't want to do that. Hopefully that still works. Should have been changing this, is what I was trying to do. So let's drag that over here. And we'll say read content. I was going to say lines equals content.split, where we're splitting by the new line character. And let's see what else we want to do. Well, now we want to iterate over lines. So I was going to say basically, if you print lines over here right now, this is what you get. We have a list where every element is separated by the new line. So we basically have each line. But the cool thing is that what we can do from here is we can actually split it again by spaces. And that way you're not going to have those new lines hanging at the end, right? When we did read lines, we actually had new lines hanging at the end. So we can iterate over every line and split it by a space. So we can say once again for line in lines, words, and we'll assign that to line.split by space. And now we can iterate over that. So we can say for word in words, right? If the word starts with a single quote and it ends with also a single quote, and you also actually want to make sure that the word is not an empty word, because that can happen. So if its length is greater than 0 and it starts and ends with a single quote, then we know that's a valid word. So we can say, or like not that it's a valid word, but we know that it's a word that we can replace. So now the question is, what do we replace it with? So let's make it so that you can actually pass in a list of possible words from like a word bank to this function. So what do we want our word bank to be? We can say like, I'm just thinking of random words here. Robbery. That doesn't make sense. Pinocchio. Okay, whatever. We have some random words. We'll do pistachio as well. And these are going to be our word bank. So now what we want to do is we want to use a random word each time. And let's make it so that you can only use every word once, right? We don't want duplicate words. So we're actually going to read random for this. So we can import random. And as soon as we get our word bank, we can shuffle it, right? I actually learned about this shuffle thing yesterday. Someone mentioned it in chat. So we can shuffle our list, word bank. And now, when we write to our output file, right, and we're going to do that by doing this, output file.write, we can, like, instead of that word that started and ended with a single quote, we're going to do our own version. So it's also going to start and end with a single quote. So it's going to be the same thing, but then we're going to pop from our word bank, because that's going to return whatever's on top of our shuffled word bank, and it's going to remove it from the list at the same time, which is perfect. We can just do that. And that's basically good. And obviously else, which means if it's not one of the special words that we want to replace, then we could just write that word regularly. I just realized we're also probably going to want to put spaces, because all of these words are separated by spaces. So there's no spaces in there. So we should add them in ourselves. So we'll say word plus space. And then we'll also add a space to the end of this. That way our stuff is separated by spaces. It looks okay. And we also don't have new lines, because we split by new lines as well. So what we can do is, after every line, which is in line with this for loop for lines, we could say output file dot write, and we'll put a new line character in there. That way there's a new line character. And then we can just close our two files again, so we can copy that. And that looks to be good. So let's run that and see if it compiles. It does. So we can go and take a look at our, what did we call that? Oh, I think we might have overwritten our thing. Let's rerun this, and let's change the output file name. Let's call this custom output. So hopefully there's a new file in here called custom output, but there doesn't seem to be, which is not good. We gotta figure out why it didn't work. Oh, we hit an error. Oops. That's why it didn't work. All right, we forgot to add a plus here. That would be why. Let's try running again. Don't need this print. Compiled again, and we do have our custom output. So if we open that, there we go. So I'll show you the limerick. It used to be access, bank, storage, and basic. I just realized that I put bank back into the word bank, which is probably pretty weird. But yeah, so now it's bank over here, Pinocchio, pogo stick, and pistachio. So it worked, which is pretty cool. There's a lot of optimizations and small things that you could do to this program. I'm sure it's nowhere close to being perfect, and it's also nowhere close to being efficient either. But it's understandable, which is kind of what I was going for. At least I think so. Does anyone have any questions about the limerick or the custom limerick? If you want to randomly pick something from a list without necessarily shuffling. Oh, random choice. Oh, that's smart. Yeah, I didn't know about that one. That would also work for sure. But does choice remove it from the list? You could do that separately, I'm sure. You just use the remove afterwards. But yeah, choice definitely works as well. All right, if there are no questions about the limerick stuff, we can move on to the next thing, which is also file I/O. But it's a different kind of file I/O, which is once again present in your assignment, which is working with CSV files, which are comma separated value files, I believe, which is like what a lot of Excel files and spreadsheets are made of. So what do we have to do? We have to write a Python function, which is called funniest word. Just do that here. Which selects a single funniest word from the provided CSV file and returns just that word in string form. The process to determine the funniest word is as follows. A word is not funny unless the queen thinks it's funny. To calculate the score, multiply the number of times a British comedian has used the word by 5 and then divide blah, blah, blah. If the above calculation fails, it can't be the funniest word, and the funniest word is the word with the highest score, as described above. Okay, cool. So let's take a look at what our input is. What are we working with? If you go over to sillywords.csv, which is the provided input, you'll notice that it looks like this. And we have a header line here, which is telling us the format of our table. And it goes name, usage, rating, and royal assent, all separated by commas. So the name is basically the name of the word. Usage is its usage by British comedians, like the instructions said. Rating is the rating that Canadians gave it. And royal assent, I believe, is whether the queen likes the word or not, which are all the factors that we need to determine if a word is going to be the funniest word or not. So let's get back to our function. In order to work with CSV files, you need to import the CSV module. This gives you access to the CSV reader method, which is really important here. So we can open that. Since we're only dealing with one file here, we can just call it file. We don't need to differentiate between input and output. We can open it, and it's going to be sillywords.csv, I believe so. And we're obviously reading from that. All right, and we're going to have every line. And the way you use the CSV reader is like this. You call the reader method from the CSV module, and you feed it the file. So file is what we opened, and we're going to feed it into the CSV reader. And now we stored it in lines. And if you print lines, and we add a method call to our function, yes, okay, maybe we can iterate over it. There we go. So for I in lines, print I gives you every line as a list. Here's the thing though. We have the header in here, and we don't want to work on the header. We don't want to treat the header as if it's an actual entry. So what we can do is a pretty cool method that's also part of like this kind of reading functionality, which is next. And we could feed in file. The way this works is basically when Python is reading the file, it keeps like a pointer, which helps it keep track of which line it's currently on. What this command does is it shifts the pointer over by one line. So it shifts it over to the next line, basically. So at the beginning, like as of right now, the pointer's at the beginning here because we haven't done anything yet. If we hit next, the pointer will jump over to the next one. So now we can start on this one, which is good. So let's initialize some variables. We want to keep track of what the winning word is going to be, so we can return that at the end. And we also want to keep track of what the current highest score is. Because what our strategy is going to be is we're going to basically iterate over every single word, calculate its score, and every time that word's score is higher than the max score, we're going to update our winning word and our max score. And by the end of it, the winning word will be the actual word with the high score. So max score is currently 0. And we can just start iterating. So we can say for line and lines, if, and then keep in mind each line is a list of these 4 values. So we're only going to consider a word to even be funny if the queen thinks it's funny, because a word isn't even funny unless the queen thinks it's funny. So we're only considering words that have true under royal assent, which royal assent is always going to be the 4th element in the list. So we can basically say if line at 3, right, because that's going to be the 4th element, is, we need to cast that to a string, sorry. Or, oh wait, it's already a string, no? If line equals 3 is true, then we need to consider further. We need to calculate the score. But notice that they say if the calculation fails for any reason, then it can't be the funniest word. So what I'm actually going to do is I'm going to put a try except in here. And what we're going to try is calculating the score. That way, if the calculation that we try over here fails at any point, our code can go to the except block. So we can try, calculate the score. What is it? Multiply the number of times a British comedian has used it by 5 and divide by the rating. So we're multiplying usage by 5, which is line at 1 times 5. We need to cast this to an int because as of right now it's a string. And divide by usage, which is rating, which is line at 2, I believe. That should work. That's the score. And what we're going to say is, if the score is greater than the max score, then we know that this is our new winning word for right now. So we can say max score becomes the score, and winning word becomes line at 0, which is the name, right? Cool. And if the calculation fails, then we don't want to do any of this. We don't want to update the score, max score. We don't care. We can just go on to the next one. So we can just say pass. Like we don't really want to do anything, right? And that's basically it. By the end of this loop, our winning word should be stored in the winning word variable. So we could just close our file right here, which is good practice, and return the winning word. And that should really be good. And we have an output. It says pill benagging, which I guess we just have to take the word that's true. Like you can't really verify it because there's no test cases. But where's the word? Nagging. It's right here. So the score is calculated by multiplying this number by 5 and dividing by this number. Okay, so I'm pretty sure why the score 1 is because this number is 1. Since we're dividing by this number, having it as 1 instead of a number like 98, 34, 87 means that our number is going to be a lot bigger, because if we divide by a smaller number, our result's bigger. So 46 times 5 is like 230 divided by 1. The score is 230, I believe. So we can say return winning word and max score. See if it's actually 230. It is. Cool. So that's that. And we're done. Does anybody have any questions about this function or anything that we did? involving like the file reading, the CSV reading. Because this stuff is relevant to your assignment. I'm pretty sure you have like a problem that involves file input output to a text file and a CSV file. No questions? If there are no questions, then we can move on. Because this is actually all for the tutorial content. It was a really fast tutorial. But yeah, there really wasn't much to cover at all, which is good because that means we can go over any other questions that you guys might have about assignment content. Okay, doesn't look like there are any questions about this. So we'll quickly cover this whole thing about requests, which was requested last night. Basically, the question asks you to use Python requests to obtain a response from some sort of web resource. And when you make a request to that web resource, you get a response back. And that response has a bunch of properties, like a status code that tells you whether or not that response was successful or not, and a bunch of other things, like a text property that tells you a bunch of different properties about the actual web resource and the response. So basically, whoever wrote this question is just giving you a quick briefing about what a request is, but you actually won't have to use it too much. If we take a look at the task over here, it says, I'll just skim over it. Like you basically have a weekly schedule built in Python that's like basically a calendar, right? And the phone notifies us during the week of our scheduled activity, blah, blah, using a CSV file, which is what we worked with today. It stores, for each entry, it stores the day of the week that appointment is on, the hour of the day that occurs in, the duration, and the name of the appointment. And basically, every day of the week is supposed to have the exact same schedule. But we gave our phone to our little brother and he changed 3 of the data cells. The edits cannot be on the day of the week cell. So it has to be either hour of the day, duration, or appointment. Like he could have edited one of these cells. And that's basically the point. So you're supposed to write a function that takes in this CSV file and outputs right here. It outputs a list of tuples where each tuple corresponds to an appointment. So let me show you the input that you're working with. Should have it somewhere here. Yeah, so the schedule that you're working with is actually found on Avenue. When you were downloading the assignment, you might have noticed that there are a bunch of files there. One of those files is actually required. It's this one. You guys can see my screen over here now. There's a weekly schedule. And if you open that, this is your input. So here you have a header file again. and you have all these appointments. So all of these are for the first day, and you can tell because the first cell entry is 1. All of these are for the second day, so on and so forth. So none of the 3 edits could have been these cells, like the day of the week. It had to be one of the other cells. So like you could easily just like take a look with your eyes, right, and see what the problem is. Like if you look at the hour of day, you'll see that it's like 8, 9, 12, 14, 15, 17, 90, 20, 22. But in this one, it's 8, 9, 12, 13, 15, 17, 19, 20, 22. This one, it's 8, 9, 12, 13 again. 8, 9, 12, 13 again. But back in the first one, it was 8, 9, 12, 14. So it looks to be like this would be an error. Your job is to find out, is to devise an algorithm, however you want to do that, that finds where those errors are. And I'll quickly give you some hints about that. You have to be careful because you could just like you might naively think, oh, I'll check every row. Like I'll take this first row and I'll compare it to this row, and this row, and this row, and this row, which is basically the same appointment on each day, right? And I'll find if there's any one that's different, that's the error. And that's a good strategy. You have to consider the possibility of there being multiple errors on the same thing. So if you're really unlucky, which for hidden test cases, you tend to sometimes get really unlucky, if you know what I mean, there could be a case where all 3 of the edits are on the same like appointment. In which case, you'd have 4 of those 7 days with the correct appointment and 3 of them with the wrong one. So in order to find out which one's wrong and which one's right, obviously it's the one with more is the correct one. So if you look at all 7 and you find that 4 are one thing and 3 are a different thing, then you know that since there can only be at most 3 edits, then the 4 are the correct one and the 3 are the incorrect one. So that's the help that I'll give you regarding the actual algorithm itself. But regarding the Python requests, I found a great resource here, which I will post in the chat. I would recommend everyone, like this is a very long resource and there's a lot of help about it, but I would recommend reading the first little bit. The first little bit tells you exactly what you need to do. You can skip all this installation stuff. Since you're working with Jupyter Hub instead of like a local installation, like it'll work fine. Even if you're working with local Jupyter Notebook, you don't have to worry about running anything in your shell. And it tells you you just need to import requests, and you'll have access to things like the get and post. You'll see that if you use the request module that you get and you use the get method on it, you can pass in a web resource and it will give you a response back. You can store that response in a variable, and now you can access that variable's properties in a lot of different ways. So since we stored our response in this variable that we're calling response, we can say, for example, response.statuscode, and the output will be 200, because that's the value stored in this property. And you can use that stuff to determine whether a request was successful or not, right? If you go over back to the instructions, it says, in the event that the API REST call should not work, aka the request was unsuccessful, then a spotty error should be thrown. In the event that the request fails for any reason, then you should also raise a spotty error. And the idea behind that is, well, obviously, like this should be screaming try except for you. like seeing in the event that the request fails for any reason, you should be saying try accept in your head, because basically you're going to try and make the request, and in your accept block you're going to throw a spotty error, which oops, I'm going to restart. I'm scared. But spotty is meant to be an error that you make yourself. So just like in the previous assignment, where you made all those different exceptions, you made like fire, missing, explosion, meltdown, right? You made all those exceptions yourself. Oh man, it's the same thing here. Oh no. Yeah, you're just supposed to do the same thing. So create an error, like an exception class, call it spotty, and then in either of those two events mentioned, throw that exception. Shoot, I really just messed it up or what? And I'll give you a bit more of a hint if you need to about that exception. Because the only part, please work. Yes, okay, we're back. So the only part of this whole question that involves all this like weird request stuff that you've never heard of is like a very small portion of it. He has a small example here, but the issue is that if you run it, like, at least for me, it doesn't work. And this is supposed to be like an example that helps you get started. But like, and this is like not a problem on my end. This is like a weird like server thing. So I think it might be a bit outdated because it doesn't work. But what we can do is we can just comment that back out again, and we can try something else, right? Like the issue here was not the code. It was just the fact that the server is down. So if you take a look over here at the Python request, you go back up, they use an example of GitHub's API web resource. So let's try that, right? If we run this, it actually compiles just fine. And if we try checking its status code, nothing happens. Let's try printing it maybe. There we go, 200. And if you go back over to the instructions, it says up here, if a request is not successful, then the status code property will be something besides the number 200, because 200 status code indicates a successful request. Okay? So basically what's happening is if, you know, like, I don't think I need to make it more explicit, but how do I say this? If the request is not successful, then you should be raising a spotty error. How do you know if the request is successful? By checking to see if the status code is equal to 200 or not. And besides that, you should also raise the error if you can't make the request for any reason here, right? So those are the two conditions. And I'm sure you guys know how to make an exception. It's something like this, right? That's literally all it is. And now we can raise, like at any point in our code, we can raise spotty. And this will raise the spotty exception. Very simple. If you if you follow that, you should really be set. Like the only stuff you have to worry about with the requests is just these two things. Does that make sense? For whoever asked about that last night regarding like the request stuff. If anyone has any questions, feel free to ask. Because I don't want there to be too many questions about this if there doesn't have to be. It's yeah, really simple. For the actual algorithm, okay. To be honest, that's the whole question. Is you got to find out how to locate an error. But I can try and give you some hints. The way I'd approach it, I haven't actually like written a solution for this yet. But the way I will approach it is you have to use the fact that there are only 7 days to your advantage, and you also have to use the fact that every day is supposed to have the same schedule to your advantage, right? So what I would do is I would check, I would basically collect every appointment of a given day. So the first appointment of every day is supposed to be yoga, and it runs at 8 a.m. and it runs for 1 hour, right? I would collect all of these in some sort of like list, and I would compare them all, right? And clearly in this case, they're all the same, which means the edit that our little brother made can't be in that first appointment anywhere, right? And then you'd continue on, right? You'd keep going, blah, 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 until you, like let's say you try this one. You try English class right here, which is supposed to be the 4th appointment of every day. You take a big list, right? English class starts at 14 hours, lasts for 2 hours. English class starts at 13 hours, lasts for 2 hours. 13 and 2, 13 and 2, 13 and 2, 13 and 2, 13 and 2. So you can, with 100% certainty, say that this appointment has an error in it, right? Because even if all of the edits were on this kind of appointment, like even if this was a 14, which it is, but let's say this was also a 14, and this was also a 14 down here. Since there are only 7 days, and there can be at most 3 edits, the other 4, right, will still be 13. So we can use that to our advantage, right? Basically, the whole idea of the algorithm would be collect every single appointment, and whichever instance there's the most of, right, then that's the right one. And if there are any instances that are not the same as the one that occurs the most times, then those instances are errors. Does that make sense? So keep in mind that all we're trying to do at the end here, yeah, the maximum number of errors is 3. If you read the question, it says he edited 3 data cells in the CSV file, right? So that's very key. The fact that there are 7 days in the week and he can only edit 3 means that the majority will always be the correct one, right? Even if all 3 are in the same type of appointment, 4 is still greater than 3. That's the point. And what you're trying to output is a list of tuples where each tuple is the appointment, right? Each tuple is representing an individual row. So your result, right, is going to look something like this, right? you have a tuple here. Right? Something like this. This is one error, but you would have 3 of them. So that's the whole idea, right? You're basically going to figure out what the 3 errors are. And yeah, like these are all supposed to be strings, really, technically, because when you're reading from a file, they're all strings. But yeah, that's the whole question. So really, a lot easier than you think. And just keep in mind that you're going to be raising Spotty in these 2 cases, right? If the API IRS call does not work, aka an incorrect status code, which is not 200, or if the request fails for any reason. So aka while you're trying to make the request, when using requests.get, if that fails for any reason, then also raise Spotty. So like, I'm sure you could figure out how to do that using try excepts. All right, guys. That's the whole tutorial, and we also had like just enough time to cover question 3 from the assignment, which was, to be honest, kind of the trickiest one, I think. Does anybody have any questions about anything that we've covered today? I'll be you can take a look at this. This is on Avni, by the way. This is in the same Avni folder as your assignment 5, and I'll save these, and I'll also upload the tutorial 7 thing to Avni as well. All right, looks like no questions. It's pretty good. Thanks for coming, guys, and good luck with the assignment and your test. I'll be there on Piazza, and I'll also see you guys next Monday. See ya.